Good morning, friends. Today we have assembled on the occasion of inauguration of CSIR OWOT-EED program, that is Energy and Energy Devices, on harnessing high performance computing for innovation in energy solutions and technologies. At the first instance, I request our director, ma'am, Dr. Sridevi, to please come on the dais and accompany our chief guest of the day, Shri MP Ramesh sir, onto the dais, please. Also, I request Parveez sir and Ashish to please come on the stage. Thank you. Yeah, we'll begin our program by invoking the blessings of the Almighty. I request the dignitaries on the dais to please light the lamp and begin our program. Thank you. Now I request Miss Shubha for the invocation, please.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि. Thank you.
Thank you, Shubha, for invoking the blessings of Lord Ganesha. Now, I request our Chief Scientist, Dr. Imtiaz Ahmad Parveez, for welcoming the August gathering and also to introduce the chief guest to us. Please, sir.
A very warm good morning to all. Shri MP Ramesh, chief guest of today's event, and Dr. Sridevi Jade, our director CSIR 4PI, Dr. Mutkavi, our former head, Dr. Ashish, who is coordinating this event, all dear colleagues, friends, and young students who have come to participate in our event. Very good morning to all, one and all. So, on behalf of our institute, I extend a very warm welcome to all of you, and I request our director, Dr. Sridevi Jade, to please welcome Shri Ramesh with a bouquet. Thank you. So last year, our Honorable Minister for Science and Technology and Vice President of CSIR, Dr. Jitendra Singh, gave us 1 week, 1 lab event, which was a countrywide initiative of CSIR to showcase the technological breakthroughs, achievements, and scientific innovations of all the CSIR laboratories. So that OWOL event was a grand success across the country, and we at CSIR 4PI also hosted this event very successfully in July 2023. So OWOL was concluded on the CSIR Foundation Day, that is September 26, 2023, and in continuation of the same thought, this year we have been given 1 week, 1 theme. Hence, today we are here to celebrate and participate in this initiative, which is a part of the Energy and Energy Devices EED theme. And our title for this today's event is Harnessing High Performance Computing for Innovation in Energy Solution and Technologies. So we all know that CSIR has 37 laboratories, and all of these labs are working across 8 themes. For example, number 1 is Aerospace, Electronics, Instrumentation and Strategic Sector, that is called AEISS. Then Civil Infrastructure and Engineering, CIE. Mining, Minerals, Metals and Materials, that is called 4M. Chemicals, including leather and petrochemicals, CLP. And Energy and Energy Devices, which is today's event, Agri, Nutrition and Biotech, A and B. Ecology, Environment, Earth and Ocean Sciences and Water, that is called E3OW. And then finally, Healthcare. So these are the 8 themes where all the CSIR labs are working together, and that is the event. That is 1 week, 1 theme. So one theme, for example, this Energy and Energy Devices is the theme which is going on this week, and similarly all other themes will come, and then we will have to celebrate for this 1 year. So this year again, all the labs involved in respective themes are showcasing their research and technological achievements throughout 1 week. Our institute fortunately contributes horizontally across all the themes. So we will have many more themes to come in the few months. And in this opening week, the curtain raiser of this event was done at CSIR headquarters on Monday, that is June 24th. And the event was inaugurated by NCL Pune. So today, when we are organizing this event, I think that we could not have had any better chief guest than Shri MP Ramesh, who is presently the President of Wind Resource and Technology, YU Power Corporation Limited. Now I would like to give a brief introduction of our chief guest. He is the founding managing director of Garad Hassan India. He has brought into the country one of the most celebrated and respected consulting houses with an unmatched track record. As the first full-time executive director, Center for Wind Energy and Technology, he put in place an organization to provide end-to-end solutions to the field. In a short span of 6 years, CWET became a center of excellence and is one of the best R&D institutions set up by the Ministry of New and Renewable Energy. In his successful career, Shri Ramesh has had a long stint at CSIR NL as a scientist and head out of Wind Energy Division. He formulated and implemented several forward-looking programs, participated in national efforts for resource assessment, testing, and certification research. He has represented India in the Electro-Technical Committee meetings on behalf of India and has chaired the BIS Committee on the Wind Turbine Standards. Shri Ramesh holds a master's degree in mechanical engineering from the Indian Institute of Science and a master's degree from Oldenburg in renewable energy technology, both postgraduate degrees with distinctions. With a grassroots level and policy level management experience of over 45 years, Shri Ramesh is a recognized authority on the subject. He is currently involved in increasing weather forecasting accuracy by making available more on-site meteorological data from wind farming areas as an input to global models. It is hoped that this approach will result in a paradigm shift in better absorptions of renewable energy power into the national grids. So we are really very glad, sir, that you have accepted our invitation to be a chief guest. Thank you so much. Thank you.
Thank you, Pavi sir, for the brief introduction of chief guest. Now I request the audience is much waited, including the students, to hear your lecture, sir. I request you to please come on and deliver your address.
Thank you very much for this invitation and an opportunity to share what I have learned over several decades. And I hope at the end of the lecture you will be a little bit impressed and you will see big opportunities coming your way if you want to do it. Thank you. Has the presentation come up? So basic theme of what I want to say today is wind power. It's an opportunity to innovate because there are plenty of things that you could do. So briefly, I will give you some aspects of what all has happened up till now. What is the canvas that you are looking at, and some small, very small introduction of what wind energy is all about, how the whole thing is put together, because most people will not have an idea. Because the moment I speak of wind energy, they'll think of a water pumping windmill. Things have gone way beyond that. So I will give you some introduction of that. And of course, all said and done, it is quite difficult to absorb renewable energy on the grid. So there is a bit of resistance, which is good, which is healthy, so that we do our job better. And what are the challenges and opportunities. And one sample area I have tried to showcase here and how to go forward in that direction. So that's the idea, because it's after all a mathematics institute, I should show you something which is very mathematical and interesting for everybody, at least most part of the people. So Government of India has a very ambitious plan of achieving 500 gigawatt from renewable energy sources against roughly 400 gigawatt of firm power by 2030. It's an extremely ambitious plan. If you put it all together, you're looking at 950 gigawatt of installed power across the country. It's a huge thing because I put gigawatt. If I talk in megawatts, you will say, oh my God. So gigawatt is slightly more easy to understand. Of this, 160 gigawatt is expected to be coming from wind, and currently we are at just 46 gigawatt. So field is wide open, lot of things to be done, and of course the current emphasis is on solar, not so much on wind. In fact, we face more difficulties because the solar coming in, but it's okay. It's a good challenge, yeah. And of course, there is always a big issue about the estimation of how much we have. So in 2003, 2004, we published a India map showing where we have wind power and what is the extent of power we have. At that time, it was a very modest 45 gigawatt. That's about it. But that time, when we made those estimates, we also considered the grid availability. You can't simply generate in vacuum. So you need to have a place to send the power off. So that also was taken. For example, in Karnataka, you take the grid size is hardly 5,000 megawatt, the 5 gigawatt. So on that, you can't, at that time, there was a thought process that you cannot accommodate more than 10 to 15% of renewable energy. So we scaled it down. That's how that number of 45 gigawatt was put up. And new estimates came, because this was again forced from overseas. There were several Harvard University, I don't know, some universities said, no, India has more than 3,000 gigawatt, so on and so forth. So there was a lot of pressure coming on the scientists of government to say what it is. So then they made a revised estimate. They said, okay, it will be around 700 gigawatt at 120 meters elevation, and about 1164 gigawatt at 150 meters above ground. And these are the official estimates. Every day there is a new estimate coming. In 2024, same university which gave the original 3,000, now they have scaled it up to 10,000 gigawatt. It's just a way of looking at how we say these numbers. You can't simply go by these things. But 700 may be more like it, you can probably achieve. And looking at the backdrop of all India of 46 gigawatt, the original estimates made in 2003 are still worth it, because after 20 years we are still at 46. But now we want to scale a much bigger level of 160 gigawatt. It will probably happen, at least half of it comes, it's very grand, right? Then there are other issues with it. Now, which state has done what, we have tried to capture here. The total available capacity, as I have shown here, is some 1164 for 150 meters hub height, and about 700 gigawatt for 120 meter hub height turbines, if I look at that. But now turbines are growing quite tall. They are going to 140, 150 meters hub height. So you can imagine 500 feet above the ground you have the rotor turning. So it's a very grand thing. And of this, the most attractive state is probably Rajasthan, and Karnataka also has 169, and like that, and Gujarat has 181. But the list is topped by Rajasthan. One of the perception issue, nobody wanted to go to Rajasthan once upon a time, because Rajasthan was not so windy. When I was a young scientist trying to push projects, Rajasthan we didn't want to go, because one is, of course, it's a weak resource in our understanding at that time. Now it has become most attractive simply because other places are almost full. There is no place where you can put up the wind turbine. So now you are all rushing towards Rajasthan. Although I am always a little afraid of the high temperatures and all that. So that is the state-wise division. Until recently, Tamil Nadu was the topper in the list. Now it has been overtaken by Gujarat, and followed by Karnataka and many other smaller possibilities. Now, this is a very small, brief introduction. I don't want to tell you too much about all this, because it's a matter for another big lecture. So I will not get that kind of time. So originally, what we used was a stall regulated, that the blade is fixed. It cannot precess about its own axis, and it was a fixed speed machine. It will always rotate at a constant RPM, and all of them had a gearbox, and that was the original Danish configuration. The Danes are probably, you may be aware, they were the pioneers. They still are to some extent. Now it has been overtaken by, like in every other technology, in every other field, China has overtaken everybody. So the original Danes are a little backseat now. See, from this, the technology moved on. Then you had, I don't know how it works here. Then we had these fixed speed has given way to active stall, and then continued with fixed pitch, and at some stage the pitch regulated machines became more they came more in practice, because it was far more efficient in terms of technology, uh, uh, in terms of energy generation and so on. So that became the norm, and the rotor was allowed to rotate at the maximum possible speed at any given wind speed, so that it will extract most energy. And it also became necessary that you get rid of a gearbox, because gearbox always have problems. So several designs have come without a gearbox. So whatever the rotor will be turning around, something like 20-30 rpm, and a generator is designed to generate full power at 30 rpm. So you don't have a gearbox, you got rid of a huge problem in terms of having to worry about a gearbox. So and of course there are some designs which have been there. For example, the Vayu Power Corporation was making these turbines right from beginning with variable speed and gearless generator, and it was full pitch regulated turbine. So there's nothing very big in this technology development. I will show you in the next. So original arrangement was very simple. You had a rotor, then you had a speed adjuster, and then you have a generator. All these chaps, this was all 1980, 1990 period machines, and then of course it was, in the olden days we were using the PLC to control the turbines. Now they have given away to a small microcomputer which sits in the turbine itself. And the pitching is also taken care by a special slow speed motor, and that collective pitch gave way to many other individual pitch and so on and so forth. And today, how come? Why it's not going anywhere? Stuck, huh? Oh, it takes time. Yeah, okay. So now, of course, we have gone into very big turbines. Today's turbines are enormous. I mean, they will have a rotor diameter of 150, 160 meters, and then it has, our own turbine has something like 150 to 200 sensors at different parts of the turbine, right from the generator to the pitch and the blade load. Everything is measured, and all those things are processed by a microcontroller within the turbine. They have also distributed controllers at the top and at the bottom, and the power is conditioned to receive the generated electricity. First it will of course be the alternating power. From that it will be rectified and made DC power, and then that will be passed through a IGBT controlled power supply, which will match with the grid frequency and the grid voltages. So you have kind of separated the two. Generation happens at variable speed and variable power, and that will get converted into fixed frequency as is required by the grid. So a lot of things have happened. So over a 35 years, from tractor type of thing, where you simply have a generator and then you feed it to the grid without worrying too much. Now the control systems of the wind turbines are so advanced, it will be almost like a helicopter. And in terms of sizes, way back in early times, 1980, 1985, the turbines were 22, 55 kilowatt, 95 kilowatt. Then it became 2.3. Now we are looking at almost 3.6, and our own Adani Power has made a 5.4 megawatt single unit. So it's what is important is they are the world's largest rotating machinery. So that's a Boeing 747, and when you put it against a wind turbine rotor, it is quite small. It is the size of 2 or 3 football fields, It is so large. And that actually brings you to a point where you are actually dealing with a very dynamic system. It has so many things built into it. It's quite very absorbing kind of a field. It's not easy to manage that. So some very rudimentary aspects about this design. It's a multidisciplinary engineering product. There's not a single technology. You have to have meteorology as a background, you have to have the control system as a background, and then you have composites, then you have the structural engineering, and there's structural dynamics and aeroelasticity, you name it, it's all there. So it is one product that kind of puts together a variety of very advanced science and engineering. And of course, the design goals are it should be cheap, because we have to give cheap products. We can't spend too much money but still get as much as we can. That's a human tendency. And it should be most advanced, and it shall meet all the environmental conditions and also grid managed demands. Both are very difficult, I will tell you, because you just go to Gujarat, every year we have enormous amounts of these cyclonic weather, and these turbines have to withstand those things without getting into any trouble and be ready. As soon as that thing goes down, again they have to start functioning like nothing has happened. It's not easy, because I go through that every day. Very complicated. Something or the other will have a issue. Water will get into the generator. Generator will get into trouble. So like that. So all these things have to be taken care when you do the design, and it must be safe, because these are installed in open spaces. Just imagine a blade flies off the turbine. It can fall on just anybody. You can't stop it. So it has to be designed in a fail-safe manner, and it's not a joke, I can tell you. It is very difficult to see that nothing goes wrong. If something happens, it should stop. So these are all built into the control system design, so that at any point of time, if something happens to any of the parts of the turbine, it will stop, wait for somebody to come and look at it. So that is the level of safety that has been built into the wind turbine design. And of course, nowadays, when I go to all these awkward meetings with the power ministry and various other places, they say it shall deliver full power at all wind speeds. I still don't know how to do it. How will I do that? This is something that they expect. And the other thing is, when you design a wind turbine, you will design it to produce maximum amount of power at all given wind speed. So supposing I have a 1 megawatt wind turbine, its rated wind speed is something like 12 meter per second. At 6 meter per second, it is supposed to generate 400 or 500 kilowatts. I'll maximize that 400 or 500 kilowatt. But these chaps wanted to deliver full 800 only, or 1 megawatt. I know how to do it. And the other very difficult demand to meet is that whenever there is a ramp up or a ramp down, I'll show you some graphs of what a ramp up and what a ramp down is. It should ramp up the power every time they demand. I have asked them, I say, how will I do this? Supposing wind speed is 6 meter per second, it will deliver 6 whatever is corresponding. So how do you expect me to ramp it up? No, we don't know. You have to do it. I said, okay. Then you run it at a part level, so that when I ask you increase the power. Then I said, how will I get my money? If I run my generator at half power, how will I get my money? It won't work. But anyway, they want it. And it should be the other recent most irksome demand that has been made is that it should operate as if nothing happened when the temperatures go to 50 degrees centigrade. It is physically not possible. You explain it to them, they'll say, no, I don't care. You have to design it like that. I said, okay, we'll discuss it. So we are discussing it until cows come home. Yeah. Now, yeah. So in general, wind farming is a tightrope walk. You can't do a mistake there. Grid access requirements are, with the increasing penetration, newer demands come up, because as you keep on increasing the number of turbines that come on the system, there will be difficulty, no doubt, because sometimes we give say 3 megawatts, sometimes in 1 or 2 hours it may go to 500 kilowatts. I mean 500 megawatt from 3 gigawatt, it will come to 500 megawatt. It happens. So they have to, how will they supply the electricity in those times? It's an issue, I will not deny that. Therefore, then the demands come up one by one, because they had not experienced this, so they come up with a new demand. I have to meet that. And then again they will come up with one example is there is something called LVRT, low voltage right through, right? There is a grid disturbance somewhere, because that the voltage will fall from say 32 kV to it will come to 27 kV. These turbines are designed to stop, and when they stop, it has to be restarted. Restarting takes about 2 to 3 minutes. They say no, because of you my grid will collapse, therefore you cannot allow it. So we said okay, we made a lot of new additions to the turbine. We made that. Then they said similarly now you please do it for high voltage right. We are trying to do that. Then they said temperature is a big issue, don't allow the turbine to derate. So all these things are going on. One of the primary aspects which I told you is about the forecasting of wind power, and eventually they want it to look like any other conventional power source, which is a good aim to keep, but very complicated to reach, right? And how do we make it? One is by hybridizing it with solar, or maybe some other, even a conventional generator, and then the other one is hybrid plus storage, another area. The storage business, of course, may be all right in some other environments, but not in India with its monsoon based wind system. You can't store it for 1 month, whatever you generate. So we have to think how to manage the thing. And then at the end of the day, we also have to make it very cost effective. That's another, one of the, this is not actually a graph, but I want to share this with you because it's important. There is this guy called grid operator. What he needs, initially he will think it's a ridicule for us. Kya chote for 55 kilowatt, 100 kilowatt, 1 megawatt. In my grid, what is this? This is nothing. And then there will be animosity that I have to face. Then eventually the cooperation will come. And what are the 3 main arguments for wind energy? One is it's environmentally more friendly, and then it also gives you security of supply, because you have one more source in the energy mix that you have, and then it is also least cost option. It used to be. Solar is competing with it. In reality it is not, but it is considered as one of the serious contenders. Now, where are we on these things is important. So during 1990s, early years, it was like that. And even in 2025, we face quite a lot of animosity. And by 2030, there can be some cooperation between them and us. Because although, no, we are all one, there's no such you and me, it's not there, you must not talk like that. But there is animosity. They will come up with rules and regulations which are always a little bit heavy-handed, because they run the grid. So what they say goes. And by 2035, there may be full cooperation between the renewable energy producers and the wind energy or even solar energy people. So it's an important aspect that we all have to face as the wind energy experts. So in 2018, because they changed the rules of acquisition of renewable energy, they said in the past we were getting what is known as a preferential tariff. that we negotiate with the state electricity boards, say that my cost plus model was accepted. Now, at one stage, central government said, this is all nonsense. You have been here for quite a long time. Therefore, now we'll ask you to bid. Who gives me the lowest cost, I'll buy it from you. So, people without understanding what it's all about, we were getting something like 4 rupees 50 paise. In Madhya Pradesh, we were getting in 5 rupees per unit of electricity we supply. Suddenly, it became 2 rupees 50 paise. So, the entire financial calculation went for a sixer. So, but in any case, by 2018, wind energy became the cheapest. Now it is again slowly rising, but that's how it worked. What are the different challenges we have? And challenges must always be taken as opportunities. You must know that. That is the primary intent for all the young people. You should not take, who will do all this? That cannot happen. You must turn it into an opportunity. So, resource validation, it takes around 2 to 3 years because you have to actually measure it. Nowadays, people are talking of some global data sets based on which you should be able to calculate what will be the resource in a given place and so on. But that is still, it's an opportunity if you are able to give good results. There are 1 or 2 companies from Spain which are actually doing that. They give you some numbers which nobody knows. It never gets validated. But there is a big opportunity of doing something in that direction. Then the second important thing is the site suitability and evacuation. Both are the very serious issues. Site must be okay because it has a long list of things that you need to keep in place for it to become effective. And then the land acquisition itself is a big exercise in social engineering. This you will learn only when you go and speak to the farmers or whoever else owns that land. I think it is one of the most complicated issues, and land is something that cannot come from somewhere. You have to use what we have. Earth is a small place with so many people, so there are very serious limitations on that, and you have to be very good at social engineering. You must know how to speak to the villagers, you must know how to speak to the government. Only then you will get some land. So, the other one is grid extension. Supposing I install my wind farm in some God-forsaken place and I have to run a 300 kilometers transmission line, it's not going to happen. So, we have to see how to deal with that. And just in terms of permits, there are something around 36 different permits that we have to obtain to set up a wind farm or even a solar farm. It's not a joke when you have to go to so many offices. Every fellow has a objection first, so you have to overcome that. And then even the last one, the right of way issues, this will haunt the projects forever. Even after you install, to get access to your wind turbine is always a big issue. Because once I had to conduct some measurements and I had to take a crane to one of the wind turbines. In Gujarat, they don't build compounds. They build it with stones, These fellows came to know that we have a plan to move the crane to the wind turbine. Overnight, they shifted the compounds so that my crane cannot turn. So, then of course, we had to do a lot of negotiation so that they will again open up the road so that I can take my crane. So, this is a simple thing, but it tells you how difficult it is about ROW issues. It is always underestimated. People don't understand that. What happened? Where do I show this? Yeah. Okay. So, where do we go from here? That is the mission mode proposal from Government of India talks about 500 gigawatt by 2030. If we consider the vastness of India, this can be done. I don't know. Presently, we are at 46. a gigawatt of wind and 85 gigawatts of solar power against 250 gigawatt of farm power. This is the present situation. This should be also seen in the light of 450 gigawatt of farm power by 2030. So that also you have to take into account. And important point is there is no constraint on the resource. It is available. What is an issue is the land availability and grid integration. Both are very serious issues. And because these are serious issues, it opens up plenty of opportunities of finding solutions for them and for problem solving research. Hi, come on. Where does it go? Yeah. So I have listed a small list of possible research areas. What happened? Yeah, I'm trying. Yeah. So possible area one is of course the resource, and then the technology itself is a very absorbing field. I can tell you, if you read, you will understand that there's so many things associated with wind turbine design. Each one is a very absorbing field, right? And grid integration is another huge area. For example, I will simply tell you, it is like this. There's something called grid stability, right? Grid stability is that it should not go overboard when a new generation comes in or some generation goes out or suddenly there's a huge increase in the load. What will happen is when such an event occurs, there will be something called eventually something called a blackout, that the entire grid collapses. It happened in 2012, 2011. We had the major northern grid collapse because of they tried to pin it on wind energy, but the fact of the matter was that there was overdrawal from the state of Rajasthan, Punjab, and Haryana and Delhi. They overdrew so much, the frequency fell to 47 hertz. So the generators could not take it, they backed out. So the entire northern India had a blackout for several hours. Then to restart a blacked out situation is a very complicated thing, very expensive thing. So it's always not a very comfortable thing. But the simple point is, it does not mean that you should narrow down everything so that it will not go there and trouble everybody around. They don't have a method of determining the onset of possible stability issue with the grid. They don't have it. They don't have measurements. They simply have a frequency meter which keeps on seeing how much is the frequency. Frequency is 49.5. Then somebody will take an action. Mostly they will take out the load so that frequency will again rise, or they'll ask some generators to come in. But scientific part of it is not addressed. So I always see that, of course, I try to convince many of the power system engineers to please look into this. Find ways of being able to determine, nowadays there's so much of mathematics available. You can do what is that, neural network, God knows, so many things are there. Please use that and find out at least a few seconds before so that you can take a corrective action. It is an area that has been left largely untouched, at least in our country. So we have to look at that. And then then of course the grid integration is a major issue, as I told you. Then policy is another area which is unfortunately political. Policy, although we may say anything, there are a lot of politics in that. It's not an easy thing because it gets garbled. The idea may be very easy, but because of politics it gets garbled. You see, for example, we have wind-rich states and we have non-wind-rich states. The wind-rich states, people they encourage renewable energy. They get into trouble when they have to be on the grid because they start paying penalties because government has made such rules. Now, people who do this policy, they are from the northern side. sorry to say this, they will say, hey, you have to supply. Why? What can I do? Then the states which are producing more renewable energy, they'll start putting blockages for the people who want to increase their renewable energy. So a lot of things are there about that. And then the resource quantification is always a big area. You can go on and on that. And then managing high degree of variability of renewable energy is not a joke. So there's plenty of opportunities to work backwards and see, this is what I have, how do I manage it on the grid? So plenty of things can be done. And then the second, then the other one is the large scale storage of energy, because like I told you, wind is available up till from June, July, August, September, and then it dies. October, nothing happens. So what do I do in those times? Can I store this energy in some place? And then over a day also you have plenty of variations that happen. Early mornings and late evenings you have high wind. During the day there is no wind. How do I deal with it? So these are all the way. How can I store only that much energy so that I can go on? For example, in solar, you get it only for 6 or 7 hours, but you need the energy service in the night, so you need a storage. How do I do that? So these kind of, there are plenty of possibilities are there. And at machine level energy storage, so that for short term variations you can probably have that short term like an accumulator, you can do something with that. A lot of how do I size that and so on. And then the next one, the forecasting accuracies. I have a slightly longer few slides for that. And then small wind, because this is a very attractive field, but not much money, so nobody cares for that. But there is a demand for such a thing. Because I have come to Paradigm Institute, I have one thing that is directly connected with mathematics. So I am talking of the forecast stuff. And when RE generation in grid increases, grid management poses a very huge challenge. No doubt about that. They need advanced information on what would happen over the next hours to days, and be ready, just so that they can be ready to face those that kind of a situation. Electrical grids are always made to be maintained at net zero. That is, what comes onto the grid has to go out of the grid. There is no storage on the grid. This is a point 90% people have a problem in understanding. Nothing can stay on the grid. It will come in and get out. So how do I do that? They want it for every 15-minute intervals. That is at 10 o'clock or from midnight to next midnight. Every 15 minutes, what is it that you are going to give me? You must give me a list. So 96 time blocks I have to give the generation. And what is available globally is once in 6 hours. So 6 hours has how many blocks? Can somebody, some young student tell me? 6. Yeah, I just want to know how many of you are awake. Sorry. Yeah. Anyway, you see, in 6 hours, for every hour you have 4 blocks. So 24 blocks. You have to make a guess of what it will be. And it's very hard, I can tell you, because the sequence, of course, all these Arima, Tarima, all that things are there. But sequencing them in a correct manner, although it may be statistically correct, it will have same standard deviation, it will have same median, it will have same everything, but which happens after what is very difficult to guess. And this is at this time it is a burning issue. No solutions have been found for that. That is the problem we have on hand. Existing systems are woefully short. They are unable to capture it in a proper manner. We need to improve forecasting accuracy. There is no shortcut. the problem at input data level, weather data collection itself. We don't collect enough data because we collect probably 2 times or 4 times a day. That measurement time only. If you know WMO definition of that observation, they measure it for last 10 minutes of the hour and say that that is the average value for that. And that is supposed to hold at 8:30 he takes the reading, 8:30 10 minutes data, that's all, 10 or 3 minutes. And again at 5:30 he takes one more reading, that's the data. So you have 2 data points and at 500 locations across the country, and you know how large India is. It is somewhere, and they are all in the middle of the city centers, town centers, where trees are grown, and you don't know what reading that, and I don't know when they calibrated those anemometers and their instrumentation, but that is what you have. Now, this data is used as input for NWP. So it's a very dangerous thing, because you are not, see, if you are not giving any data also, it's okay. You are giving a wrong data is very, very difficult to deal with. So what we need to look at is, we have to probably come up with high resolution models, NWP models, which work on a smaller domain, not like global domain, and that will, and nowadays of course they speak of this HRRR models, high resolution something, right, and they are yet to see the light of the day in our country. They have started doing it in US in a small way, and they have found good success because they have got those numbers and there is enough proof to say that that's the way to go. And we have not even started. Therefore, there is a big opportunity to work with what we have. I am not saying that we should ape what someone else is doing. We have our data sets, we have our way of working. For that, we should see what are the things that we need to do so that we can start doing this limited areas. And we need to move away from the control by commerce, because now what is happening is, I'll close it in 2 minutes. Yeah. So today what they do is they simply put a fine on me. The generator has to pay a fine if he misses his forecast. That is not the way, because you are asking somebody who is not a meteorologist, who is not doing global modeling, you are asking him to do it. And if he does not do it, he will say you pay a penalty. So it's very hard. Or they must go into full market mode. There is no supply of electricity to the grid. You sell it in the market, you take your money. That is slowly happening now. Yeah. So numerical forecasting currently is what I think all of you know about it. Numerical weather prediction gives global weather forecasts with 6-hourly intervals. This would be interpolated to wind farm site, and wind speeds are determined. This interpolation is both spatially and temporally. Based on the past data, the conversion between the wind farm wind speed and power is determined, and this should be corrected by using immediate data. We do supply them the SCADA data from the turbine, with which they correct the outputs what they produce, and then give it as a forecast. And it's a dynamic process. It needs to be trained with lot of past data, and we do that. I mean, we give the 2, 3, 4 years of SCADA data, based on which they do the backward training of the model, and they use that as the model. And of course, because we are monsoon based, so what I am saying is, if I simply use March, April data, or maybe June data, I try to use it for December, it will not work. So I have to do full year scaling for that, I mean training. So I use that particular model to give the numbers. Sometimes it doesn't work. Where do I show this? To this? Okay. So this is how it looks. You know, this is the. This is also. See the forecast wind speed is this, which is slowly going, and actual is the which is quite wavy. You can't really predict it correctly every time. It goes haywire. It captures probably the trend to some extent, but not the actual numbers. This is from 2 different seasons. And how does the output come? It is like this. You know, you have oh my God, this is bad. So this is forecast wind speed and the actual wind speed on the CSIR. So what happens is, it's all over the place. Which value do I take? I don't know. And this, when I put it on the when I do the conversion to the power, the actual power to the forecast power, it's all over the place. So which value do I take? What is that number I have to give? Then you do all sort of statistics and come up with some number which will be invariably wrong. Yeah, because every time I have to pay a penalty for every 15 minutes. I have no choice in that. Oh, sorry. This, of course, here I am a little worried. Hey, why does it not? Okay. So meteorological carried out are carried out with a view to be able to predict development of atmospheric conditions, and this will be over a large time scale, minutes to weeks. These observations are made at prefixed times by meteorologists around the world. The data thus collected would be used to calculate what will be the state of atmosphere in the near future using mathematical models. Essentially, atmospheric modeling is rooted in equations of mass and momentum conservation. This is that Navier-Stokes equation. Don't ask me to write that, I don't know. They say that. Before we get into this is mathematics institute, so I am always a little nervous. So before we get into this, some background understanding will be helpful. I'll try to give that. One is, of course, see, atmospheric motions are chaotic. There is nothing that you can make a number, and it's not like calculating the shaft diameter. There is a formula you apply, you get the shaft diameter. This is not like that. It's very complex because the chaos in the atmosphere, and any measurements is always associated with some uncertainty. These are things that you already know. I don't have to tell you, but that at this point has to be kept in mind. Any measurement has an uncertainty. If somebody says that this is wind speed, because the measurement uncertainty, it could be, supposing 6 meters per second, can be 6.05, it can be 6.1, it can be 5.95. You don't know. It is in that range. So that uncertainty must be kept in mind. That being what it is, it has to be understood that the accuracy of input data is extremely important. And if your instruments have a large measurement error, the output also will have large measurement error. So the chaos in atmosphere are attributed to Lorentz, who stated the chaotic nature of the atmospheric flow has been popularly described as when a butterfly flaps its wings in Brazil, it could lead to a tornado in Texas. So that is the kind of chaotic behavior atmosphere has. But it may, what it essentially means is that the outcome of the model output can be very different. That's what that diagram on that side also shows, that you start something somewhere, immediately after that you do something, it may go completely to another place. The outputs are always a little bit of a questionable. There's a huge question mark on that. They have found ways of dealing with it. While it may not be as dramatic, it is essentially implies that there is a lot of unpredictability and uncertainty associated with atmospheric flow. Develops in time and space. In both time and space, it's both domains you have an issue. Yes. So at this time, how it is done, at least wind power forecasting I'll share with you. Observations are made at synoptic hours by meteorological departments around the world, and they like India, we have, you know, country 1 to country N, and IMD is one of them. They make these measurements. They all give this data to World Meteorological Center, and they will do some quality control, and that's if some very unrealistic numbers come, they kind of adjust it by making assumptions. And there are a number of people who do this numerical weather prediction. There will be any number of people who do that, both government and private. Everybody does it, and all these outputs are available for a cost, and that will be taken by a service provider, and who will give, in other words. And in India we have added one more go between the generators and so now in India we have added one more person called a QCA, who is supposed to put all these numbers together and then give it to the electricity board, right? So, but unfortunately the generator's role begins and ends right here. He does not do anything else. They're all done by government organizations mostly, but we are asked to give the numbers very correctly to the load dispatch center. It's a tall order. We have been struggling that for now, I don't know, 10 years now, because 2009 I made my first presentation to the CERC about it, but since then the quarrel has been going on. How it is done is that of course they take all these outputs from measurements around the globe, and then all those measurements are taken, and then there is a wind farm model where you have the wind farm output, and then you put it on a power curve, convert the calculated wind speed into energy, and say that this is what I'll get. This is again a season based power curve. What power curve I use in June, I will not use it in the month of May. So there will be a difference. Every month I have a new power curve which I use for each of the wind farms, and then they produce what is known as a range of outputs. This again, of course, all the mathematicians will be very happy about this P50 value, P90 value, all that, and these numbers are, of course, these outputs are given to any end user who needs it, and the important point to note is that these calculations take a long time. The global stuff, this will take 4 to 5 hours, and then they have the pre-processing, then they have the post-processing. With all that, ultimately you will get only some average values, which comes in once in 6 hours. But the grid man wants it once in 15 minutes. It's a tall order. You have to somehow meet that target. Therefore, there are quite a lot of useful things coming in that. This I wanted to share so that you will understand how the whole system is set up. See, you see this, the things which are in the yellow place. These are all the meteorological stations, surface stations, where the data is picked up by IMD, and then that will be sent to a central place, that is WMO, and then with that they make these numbers at these grid points. These are about 30 kilometers by 30 kilometers spacing. So this data comes in, and then wind farm is not going to be in one of those places. It can be just anywhere. So you have the wind farm here. So you have to use the these corner values to calculate what it will be, what will be the wind environment in your wind farm, and make these numbers. So all along the way, one is I have a problem with the measurement, then I have a problem with assimilation, then I have a problem with the downscaling, and then again I have to put it in my wind farm. So everywhere we accumulate uncertainties, which will add bigger numbers. So I say that next hour I am going to have 300 megawatt coming. It may be only 50 megawatt. So it's very hard. That's how it goes. Very surprised. Okay. So this I'll skip because there's not much time left. There are two ways. One is deterministic, where you have all the numbers with you, you do put it in a formula, you get your output. Other one is the probabilistic forecasting, where you calculate a P50 value, P95 value, P5 value. You are allowed to choose whatever number you want according to your convenience. So the idea is that there is something called ensemble prediction. You make a small variation in the input to your model and get a number of output numbers, and then you are do a statistical come up to your final number. And the other critical events which I told you already in the beginning is the ramp event. So over a day the wind speeds fall, therefore the output falls, and this is a ramp event which requires a different treatment. You cannot do it with your steady state numbers. So that ramp event needs a special way of doing those numbers, and then give it to them, because they need these very precise events. So why I am showing you all this is, there are all areas where a lot of new thoughts can come in. So what is happening? Yeah. So what we have done now is that this is all the red dots out there are all wind farms, right? What we have suggested to government is that I will give the wind speed and direction data. Please take it from all over that place, and wind speed and direction I'll give it from there. And then we discussed this matter with NCMR, WF and IMD and all these people. They said, oh, I need pressure data, I need temperature, I want humidity. I said, windmill does not measure those things, so I can't give you that. But what we can probably do is that we can install automatic weather stations in the substations, right? From where I'll pick up the power pressure, temperature, all that data. And then they say, this is a good plan, we'll do it. Now for Gujarat, then they said we'll do this experiment in Gujarat and Rajasthan, because that is where the forecasts normally go pretty bad. So let us try this method in those states. So then what we have done is, we have said that we shall try to install one automatic weather station in each of these circles in a substation, and will port the data to the NCMRWF online. See, that is other very grand thing that has happened. There was a time when I don't know, you will not even believe, when I started my career as a scientist in NAL, I was using strip chart recorders to record data. Strip chart record. Then I take a scale, measure everything. Then came the data loggers. Data log again offline. I was actually sending people to all over the country to pick up those EEPROMs on which we have the data. Now there is no need. Every morning, evening, I have online connectivity with my data loggers all over the country. So there is a paradigm shift in that area. So we want to make use of that, and we get this data to NCMRW. So instead of saying that there is no data, now we will give you data. Now do a better job. So that's the idea. Now, of course, they are quite gung-ho about it. They want to do it, which is it took me about 3 years to get them to this point. It is a grand thing. I feel quite happy about it. There are very many interesting areas for applied research. And of course, I will warn you, don't simply jump on the bandwagon of AI and ML. Please first understand the problem. That is what most of us do. Hey, I have this new tool, with it I'll do it. Only a bad workman plays with the tools. Tools are good, but you have to know which tool to apply at what point. Otherwise, you will be making a mess of it. There will be another AI cloud. Nobody knows what to do with it. So learn the science behind it, then apply, it will all work. Eventually it will happen. There no and of course the commercial angle to the whole thing is very distracting, because I find it very difficult, because at most of the time you have a scientific issue which you have to solve. Now if you start worrying too much about money, It's not going to happen. So this must, we have to come out of that. In fact, we, of course, you know, with 45 years I have interacted with the Firangs and I have interacted with Indian scientists. One learning I have got is that we have everything, but we are not doing anything. We have to come out of that. Then we'll see some, because you know, young people, when I used to meet the young engineers from Covi Consult, Ramball, they're not any better than us. Only difference is that they are willing to work at it and get the results. Here, when I speak to my own engineers, sir, very difficult, sir. We need time, sir. He will not do anything. That is what we have to come out. That is what makes us always look at Europe or America to do things, where actually we have everything with us. Why we are not using, I don't know. So
And also it will be the same Indians. Will be working.
it's a mix. Yeah. What I say is that please think about it. Don't. Today you can do a lot of things. I don't know. In my time also there was possible. Even now it is possible. So I hope to. I hope that you all see an opportunity in the field. Plenty to do. Thank you very much. Thank you.
So thank you very much for enlightening us on the wind power, the turbine design, wind farming, the challenges and opportunities that you have been facing, and also in setting up the wind farms. And we all wish you achieve the target of 500 gigawatts by 2030. We must first, no sir, to meet demand, to meet their demand, yeah. Now I request our director ma'am, Dr. Sridevi, to please give a presidential address.
So now it's almost afternoon, so I'll say good afternoon and welcome to the students from, I have a college names, I can't remember, engineering students from, from Cambridge Institute of Technology and Nitte Meenakshi Institute of Technology, and science students from St. Joseph's University. We are glad that you are here today to participate in this event, CSIR's 1 week, 1 theme event of energy and energy devices. A warm welcome to all of you, and we have a perfect chief guest, Shri MP Ramesh, who has worked almost all his career in this field, and it's an honor to have you, sir, here. A real honor, and that you spend so much of time to give this talk, which I'll come to it in the later part of my address. And all my colleagues from CSIR 4, to them also a warm welcome. So I would, this program actually was inaugurated by Honorable Minister of Science and Technology, Dr. Jitendra Singh, who is also a Vice President of CSIR in Delhi on 24th June 2024. This formal inauguration of this OWOT, which will be organized. It's not a kind of celebration, it's an event which will be organized by all 37 CSIR labs spread across the country. So, and we are one of the 37 CSIR labs, and all the CSIR labs basically work in varied fields, starting from nanotechnology to healthcare to minerals, materials, like in the welcome address Dr. Parvez said, and so many diverse themes, basically for the benefit of the industry and the society at large. So this will be celebrated across all the labs, but in theme wise, 1 week each theme. So it started on Monday 24th, because and then it will end in December. So this is basically was a brain child of our Vice President CSIR, who said that we should have this event. Because last year he said we should have 1 week, 1 lab. So that time we each lab showcased their capabilities and what they are doing in a week's time to industry academia. See, this serves two purposes. One is you showcase your lab, and you also tell that academia and industry that this is all we do, and we are willing to do this. If you have any requirement, we'll be willing to work with you. So that is how it is. So now this year we are doing it theme wise. So like I would not go into the details of themes, which already Dr. Parvez said. So we have around 8 themes. So theme wise they start now and it ends in month of December. So the whole idea behind this is that we kind of tell, not only like for students, it's like we are telling this is what we are doing, but then when there are labs which you are having academia, industry panel discussions and all, where we invite industry, and industry participation in this particular theme is really good, energy and energy devices, and they had the maximum technology transfers in front of Dr. Jitendra Singh on Monday. Compared to all the other themes, the EED theme had around 7 to 8 TOTs that were transferred in the august presence of our Honorable Minister. So this is one of the themes where the industry participation is huge, and NCL is the National Chemical Laboratory is the coordinating lab for this theme. So CSIR 4Pi is participated in the inaugural session at NCL Pune, and then we are organizing it in 4Pi today. So in this week, any one day we need to organize, so we organizing it today. So you have a huge program which actually I feel the best part of it is our chief guest talk, because it was amazing. For me it was really amazing. Absolutely, I was, before he came here, I met him in my room. So I was telling him about how any program becomes success or failure. It is not that a scientist doesn't have a passion, but then he has a passion, then he works for it, but then there are some external factors which make it a success. So I think his is a huge success story in wind energy, because I vaguely remember him as a scientist at NAL, and from then to now what he has done is like he thoroughly followed his passion, and then he kind of, so I was just talking about it, and then now I feel that he is a living example of that. Very nice to see a success stories like this. And his talk basically covered the complete, I was thinking whether he'll come to NWP models, climate impacts, but then he covered that also in the slide. So it is a completely holistic about this talk, and it is a very, and I'm glad that we are live streaming it, because it will be available on our website later on for people to look at it also. So that way it is good that we are doing it this thing, because the inaugural session is being live streamed. Then coming to our 4th Paradigm Institute, we are the youngest lab of the 37 labs of CSIR, and we are a data science institute, as all of you know. So I just thought, since there were students here, and actually now we are entering the 5th paradigm, so maybe we should consider renaming our institute. So the first so you may be wondering what are the paradigms, like of science. Like our chief guest has spoken that about Max, so that is the standalone science. And the first paradigm is observation, when you observe something and say that, oh, this is how it is today, it has moved from here to here, so tomorrow it may move this. That is your observation. Then you have a second paradigm is where you write fit equations for it. So that's the second paradigm, and solve it analytically without computers. When it becomes very complex, the problems, when you solve them using computers, it's the third paradigm. So we were a center in the third paradigm of science. Now we are come to data science. So we are now a national lab in the 4th paradigm of science. So basically this was set up basically to for CSIR to fulfill the needs within the labs also in the data science arena, and also the needs of the country. So we had to make a starting somewhere, because now data science is the in thing. So that is how we became a lab. And like you heard, we are a horizontal across all themes. So this is first theme we are doing. So maybe we will do the other themes also based on our time and the effort involved. Maybe each day for each theme during that 1 week. So that is how it is. So we have basically, all of you will be seeing, we have a supercomputing facility hosted here for the whole of CSIR. So that you will be seeing, and you have a very nice program today. So I think you would see, first you listen to Dr. Kavita Joshi on the how they use the supercomputers for energy applications. Then you have talk on the architecture and all. Then again on the how you use AI for wind speed prediction by one of our scientists. And then you see the supercomputer. So it's a golden opportunity for the students here, because you know you don't get to see a supercomputer and also get to learn about it in so much detail. So you must utilize without getting tired and sleeping off during lectures. But now, as of now, I didn't see anyone sleeping, so I think it continues. You make the best of it today, and that should be, and you can don't hesitate to ask questions. When you are talking, you can any question, anything you can ask. There is no, because you know here we work in interdisciplinary data research, so it's not a big thing, and we also have experts from, so anything you have, you can always question, you can ask whatever, however silly it may be. Even like when he asked, you know, everybody, all of you were saying 4 hours, 24 hours, but no one is saying it loudly. Even if you are wrong, be confident, it does not matter. If you are wrong, you learn next time. That's all. That is how it should be. So with these few words, I conclude my address and wish you all the best day today in our organization. Thank you.
Friends, now we have come to the end of the inauguration program. Of course, you will be having lectures in the second part of it. I request Dr. Ashish to please deliver a vote of thanks.
A very a very graceful and shining afternoon to everyone, to our honorable dignitaries at the dais, my colleagues, and all the participants who come here to attend this event. Now it's my privilege to propose a vote of thanks and acknowledge the contribution of those who has contributed and worked hard to make this event possible. Now first and foremost, on behalf of my institute, CSIR 4th Paradigm, I extend our deepest gratitude to our chief guest, Shri MP Ramesh, for gracing us with his presence, and he has given a very informative, detailed talk on wind energy, right from like design of winds, problems and challenges and opportunities, right? So I am sure that it will really encourage the young minds who are participating in these events. Now I request our director to present a memento to our chief guest, Shri MP Ramesh, as a token of appreciation. So once again, thank you very much, sir, for accepting our invitation and giving such an informative talk. Now, I wish to thank our Institute Director, Dr. Sridevi Jade, for her unwavering support and trust in us. Thank you, ma'am. So, an event like this cannot happen overnight. Preparation starts weeks before, and it requires a detailed planning and execution. So, I thank Dr. Imtiaz Parvez, in charge TMD, and Dr. G.K. Patra, Chief Scientist, for providing a comprehensive overview and support throughout this event. Thank you, sir. And our sincere appreciation also goes to Dr. Mutkavi for providing his invaluable contribution in technical discussion and planning of this event. Thank you, sir. And my sincere thanks to Dr. Kavita Joshi from NCL Pune, and Dr. Asha and Mr. Prabhu, who will be talking about HPC, AI, and their role in advancing energy solutions. Thank you being part of this. And I am also grateful to Radharamni and his team from Director Office for providing all the logistic support. Your effort ensure the smooth execution of this event. Thank you. And I extend my appreciation to entire administration for providing all the support in timely manner. Thank you. And at last but not the least, thank to all CSIR 4PI team, including security, HLS, everyone for their support to make this event successful. Thank you. Have a great day. Thanks.
जनगण मंगलदायक